Hey everyone, we are going to get started with our next installment of our circles unit. So in the last section, lesson, whatever you want to call it, we looked at just definitions of parts of a circle, and we also looked at central angles, and we saw that the measure of the central angle is equal to the measure of the arc that that angle goes into. We looked at the definition of inscribed angles, but we're going to look more today at their measures. So looking at this picture right here, we see that in the diagram, that angle BDC, which is right here, is an example of an inscribed angle. Is an example of an inscribed angle because it lies in circle A. The vertex is on the circle. So this point D, its vertex is on the circle. Okay. Now it corresponds to central angle BAC. Now why does it correspond to that? Well, it's because they both, here's a new word, intercept, I spelled that wrong. So let's see. They both intercept the same arc. So if you were to trace out these two angles, they both end at arc BC. Okay, so that's called an intercepted arc. That arc right there. You're going to want to add that definition right here to your toolkit. What is an intercepted arc? It's an arc with endpoints on each side of the angle. And I would probably use this picture as your example to add that to your toolkit. So let's just do a little bit of practice first with identifying inscribed angles and intercepted arcs. Now you might be wondering why there are ice cream cones up at the top of your notes. Something that helps me, and I've heard this trick a lot, is to think of inscribed angles as ice cream cones, the cone itself, and then the intercepted arc as the ice cream on top of the cone. So like if I turn my page a little bit, you can kind of see how this angle makes the pointy cone, and then the arc makes the very shallow scoop of ice cream on top. Okay, so we're going to do a lot of this together. There's going to be a couple where I say pause the video and you try it on your own, and then you unpause and then you check it with my work and see if yours matches up. There's going to be an assignment at the end to see if you understood the lesson. So the first part, we're going to just practice naming the angle and its intercepted arc. There's only one angle there, so it shouldn't be too tough, but let's take a look. That's what I want. Okay, so we want to name the inscribed angle and the intercepted arc. I see the angle here, and I'm using a highlighter. You can use a pencil. You don't have to use anything at all, but the color visually helps me see what I'm looking at. So I've got angle QPR, and of course when you're naming the angle, you can reverse the order and still fine. So you could have said angle RPQ, and that would have been the same thing. I would avoid just calling it angle P though, even though it's very simple here. We're going to want to get in the habit of using all three letters. Now, what arc does that intercept? Easy way to tell it, if you can name the angle correctly, it's going to be the first and the last letter, because those are the endpoints of the angle. So it's going to be arc QR. And remember, we put the curve above it to signify an arc. Again, you could have said arc RQ, and that would have been the same thing. All right, pause and try to do B on your own. Okay, so the inscribed angle is angle VXW. And then the intercepted arc is going to just be VW. Nice job. This one's a pretty cool one. I like it because it happens to go through the diameter. Just something fun. Maybe we'll see more with that later. Okay, next little section. If an inscribed angle is given, I want you to name the intercepted arc that goes with it. If the arc is given, name the corresponding inscribed angle. We're going to do example A together, and then I'm going to have you pause and try to do B on your own, and then you'll unpause and see how you did. Now, it's going to get a little complicated if you're going to try to use color with this one, simply because we're looking at multiple angles and multiple arcs, so they might kind of blend together. If you're just using a pencil, it should be okay. I'm just going to use a pencil. Actually, no, I'll use color for one of them, and then I'll go to pencil just so it's not super complicated. So if I'm looking at angle DBC, so if I trace it out, go to D, and then go to B, and then go to C, I can then see my ice cream cone, my intercepted arc on top is going to be arc DC. Remember your notation, put the arc above it. Now the next one, they give me arc BC. Okay, so I'll use another color, see if that works. So here's arc BC. So there's the arc, so where's the cone that went with it? Well, I know it has to end at B and C, and in this one, the only other option, it's got to go from vertex D. So when I'm naming that angle, I could name it angle BDC. You could have reversed it and said angle CDB, and it would have been the same thing. Notice how, like I said before, the arc endpoints are the beginning and end of the angle name. All right, last one is arc DB. So here's that arc, D to B. So what angle went into that? It's called intercept if you kind of think about football maybe, and how like if you throw an interception, it's someone who's like receiving that ball even though they're not supposed to. And it's, if you think of it like as trajectory like that, football is going and then someone captures it. The angle is going and then some arc intercepts that angle. It kind of stops its trajectory. It's not actually physics, but it's a way to think about it visually. So if I've got arc DB, well, it's got to go from D to C and then to B. So angle DCB. And again, you could have said angle BCD and it would have been the same thing. Remember, when you name an angle, the vertex has to be that center letter. Okay, I want you to try B. It's a little bit more complicated, but press pause and see if you can do it. All right, looking at B, there's a lot going on here. So we need to be very careful with how we're naming stuff. All right, first one, angle EFD. I think personally it's easier when you have the angle like this because the arc is just going to be the first and the last letters, but let's look to see. EFD. So if I go from E to F to D, so here's the cone, here's the inscribed angle, and then the really weird ice cream cone on top is ED. ED. All right, arc DP. It's going to be a little trickier. So here's my arc. Arc DP. Okay, so if I trace it out, I like to start at the ends and then go back that way to see if it helps me. So I've got angle DEP. Angle DEP. And again, D and P, first and last letter. I just need to make sure that the vertex is the correct letter in the middle. All right, PE. Arc PE. Now, this can be a little confusing because which way am I going to get there, right? Am I going from P directly to E, or am I going the long way around? We learned in the last lesson that when you're looking at arcs, if it's a minor arc, meaning it's less than half the circle, it's only going to be 2 letters typically. If you want to go the longer way and you want it to be a major arc, they would give you 3 letters. So if they'd wanted me to go this way, it would have said arc PDE. But since it just says arc PE, it's going the shorter route of the two. Okay, so if it's P to E, well, where did that come from? Well, that came from here and here. So it's angle EDP. Again, I could have said angle PDE and it would have been the same thing. All right, last one. If I have angle DPE, so I've got D to P to E. So here's my angle, and it goes into this arc ED. But wait, didn't we already have one of those before? We did, on the very first one. So even though these aren't the same angles, right, we've got angle EFD, which was here. And then we had angle DPE, which was here. They're two different angles as far as where they are positioned, but they both intercept the same arc, ED or DE, depending on how you want to name it. Now, even though we don't know what these angles and arcs measure, because they both go into the same arc, we know that they're going to have the same measure, whatever that is. So that's kind of cool. All right, now that we've been able to identify where the intercepted arcs and where the inscribed angles are, let's see if we can figure out about their measures. So we know that the central angle is equal to the measure of its intercepted arc, right? So let's take a look at some examples. What is the relationship between the measure of the inscribed angle and the measure of its intercepted arc? Let's find out. So here's circle B, and I know, so that means that B is the center point. AD is the diameter, okay. And it's kind of unnecessary, but it helps us to see that AB, BD, and BC are all congruent because they're all radii. In any circle, all the radii are congruent. So let's look at 3 different examples. It's all going off the same picture, but we're switching up the numbers each time. So I would use a pencil if you're writing into the picture. So if the measure of angle A is 35 degrees, I always add it in pencil right now. So it's 35. See that? Yes. What is the measure of angle CBD? So I need to know, what is this angle measure right there? Okay. We can use triangles because we know that the angles of a triangle add up to what? 180. Yes. So angle or triangle ABC is an isosceles triangle, which means if this angle is 35, this other angle down here is 35. Let's see, 35 and 35 is 70, and 180 minus 70 is 110. So that's angle ABC. Well, angle ABC and angle CBD are supplementary because they make a straight line. So that would mean that this angle right here is 70 degrees. Cool. All right, I'm going to erase that and start fresh with the next example. If the measure of angle CBD is 100, okay, so now they're giving me this angle. What is the measure of angle A? All right, well, if this is 100, the supplement of 100 is 80. 180 minus 80 is 100. So between angles A and C, it's going to be 100. So they each need to be 50 degrees. Okay, so let's go another step. If angle A is just X, some random variable, some random value, what is the measure then of angle CBD? Well, in this one, A was 50 and this angle was 100. In the first one, this was 35 and that was 70. What is the relationship between those numbers? Angle CBD is twice as large as angle A. So if angle A is X, CBD, measure of angle CBD is going to be 2x. Now, why is this important? This is important because we know that the central angle is equal to the measure of its arc. So angle CBD is right here, and it goes into arc CD. Well, angle A, if you trace it out, also goes in to arc CD. So both the inscribed angle, angle A, right, angle DAC, and the central angle, angle DBC, both intercept the same arc, CD. But they don't have the same measure. So in this one, in letter B, if this was 100, this would be 100. But the inscribed angle was only 50. So what is this telling us? You turn your page. This is telling us that the measure of an inscribed angle is going to be half the measure of its corresponding intercepted arc. Half. Always, no matter what. And we just saw that was true. Now, there's lots of other orientations it could have been, but it still works out the same way. If you want to think of it the other way, as far as how the arc relates to the angle, the intercepted arc is always going to be twice the measure of its corresponding inscribed angle. So in your toolkit, I would add this information to the inscribed angle section, and I would include this picture to help you out. Okay, so you've got your inscribed angle, angle DEF, and whatever that angle measures, it's going to be half of the arc that it intercepts. Okay. The math for this isn't really complicated, and it's so nice because either you're multiplying by 2 or dividing by 2. That's all you have to do. Now there's a little bit more, but as far as like the algebra is concerned, it's not very complex. So let's do an example together. You can also put this example in your toolkit if you want, but I would definitely put this one. Find the measure of angle ABC in the circle shown at right. Okay, ABC is an inscribed angle. So here's my inscribed angle. And I know my angle is going to be half the measure of its corresponding intercepted arc. Uh-oh. I don't know the measure of the intercepted arc. There's nothing printed on AC. It's blank. What am I going to do? Don't worry. We already know that arc AB is 120 and arc BC is 100. Arc AC is the only arc that's missing to make up the full circle. How many degrees are in a circle? 360. Yes. Sorry, I'm getting like very strange in my videos. My son has been watching a lot of Mickey Mouse Clubhouse lately. And on the show, Mickey Mouse is always like, what do you see? And then he pauses and he waits for the kids to respond. So like, I'm kind of becoming that. My apologies if it's a little too Mickey Mousey. Now, like I was saying, we can find the missing arc by subtracting it from 360. Okay, so before I do any like dividing by 2 or multiplying by 2, I'm going to do a little bit of basic math. So 360 minus 120 minus 100 is going to give me 140. So this arc measures 140 degrees. So just for myself, I'm going to write it over here. The measure of arc AC is 140. And we know that the measure of angle ABC is going to be half the measure of that arc. So what's 1/2 of 140? It's going to be 70 degrees. Yeah, very good. We're going to go through a couple more examples together. You'll notice we've got 4 through 11 and then another 12. You and I are going to do 4 through 7 together. You're going to press pause, do 8 through 11 on your own, and then check with the video. And then we'll do sum of 12 together. Or if you're feeling really good about this, press pause now, do it all by yourself, and then press play because I'm going to walk through every single example so you can see how you did. Looking at number 4, find the value of x in each example. Okay, these are all inscribed angles. They look a little wonky, some of them, but they really are. So this 81 goes with this angle right there. It's an inscribed angle. And then x is the arc. So I basically need to ask myself, is x going to be half of 81 or twice as large as 81? So if I look up here, the measure of an arc is twice the measure of its corresponding inscribed angle. So it's going to be twice. I need to double it. And as always, show your work so you know what you're doing. So 81 times 2 is 162. So that's x. Degrees. Don't forget degrees. All right, in number 5, we've got an inscribed angle right here. 40 is the measure of the arc. So to find the angle, I need to divide my intercepted arc by 2. So 40 divided by 2 is 20 degrees, and that's the value of x. All right, next one. Here's my angle. Now, we've got a radius here. Doesn't really matter. It's not important. Just an extra segment thrown in there. So there's my angle. And here's my arc. Remember, the angle is half the arc. Obviously, you'll have your toolkit to help you remember this, but if you're just kind of doing it without your toolkit and you want to be like, which one is which as far as half and twice? If you think about the ice cream cone, it's always smallest at the bottom of the cone. It's biggest at the top. So you know the angle has to be smaller than the arc. Specifically, the angle is half the measure of the arc. So if I have to divide 92 by 2, I get 46 degrees for my value of x. All right, number 7. X is the angle, the inscribed angle, not the central angle, but the inscribed angle. And then this is the arc that it goes into. I don't know either of them, which could seem like a problem. But remember how I said earlier it was pretty cool when that one inscribed angle went through the diameter? When that happens, you know the diameter splits your circle into 2 semicircles. And a semicircle measures 180 degrees. So if I know that this arc right here is 128 degrees, I can find this arc by doing 180 minus 128. And that's going to give me 52. So 52 degrees is the measure of that arc. And now that I know the arc, I can find the angle. So I simply divide 52 by 2, and I get 26 degrees for my value of x. Okay, press pause. I'm going to also press pause and write all the answers in for these next 4 examples, and you can check your work and see how you did. Okay, here are all the solutions for 8 through 11. So check them over, see if they match with yours. '11 was kind of like number 7, where you had to subtract the given arc from 180 to find the actual intercepted arc that you needed. Okay, last bit. And it looks confusing, but I promise it's not too bad. We want to find all 6 of the angles that are listed. Now these angles are given in numbers and not using all 3 letters, which can be actually a little bit more confusing. because like before, when we were using the letters, it was easy to see what the intercepted arc was because we knew it was the first and last letter. So in this case, if all we have is the number, we actually need to draw out and trace on our paper so we can see which arc goes with which inscribed angle. Now they give us some information over here in the problem, and it's not printed in the picture. So we need to add it to the picture before we get started. So in circle S, so S is the center, the measure of arc KL is 80, and it's 80 degrees. So KL, I'm going to add an 80 degrees up by that arc of the circle. Okay. The measure of arc LM is 100 degrees, and the measure of arc MN is 60 degrees. Okay, they didn't give me the measure of arc KN. However, if I know the other four or other three, I can easily find this one by just subtracting 360, those values from 360. So over here, I'm just going to do a little math. 360 minus 80 minus 100 minus 60, and that's going to give me 120. I feel like it's going to come in important value to know all of the arcs so I can find the angles. Okay, let's get started. We're going to find the measure of angle 1. So here is angle 1 right there. So if I were to trace out, so 1 has a vertex of K. Now, where do I go? Do I go from K to L? Do I go from K to M, K to N? If this is angle 1, right here, you just have to trace along. So it goes from to L, and it goes down to M. So its intercepted arc is LM. Okay, I'm just writing that for myself. And if LM is 100, I know the angle, angle 1, has to be half of 100. Half of 100 is 50. If you get the hang of this, press pause, see if you can do it yourself, and then unpause me so you can check your work. Now, angle 2 is up here. And we have, it starts at the vertex of L. Okay, so if I trace out, 2 goes over here to K, and then it goes down here to N. So it intercepts arc KN. Arc KN is 120. I knew I needed that for something. Half of 120 is 60 degrees. All right, angle 3 also starts at the vertex of L. So it goes from L to N, and then also from L to M. So it intercepts arc NM, which measures 60 degrees. And we know half of 60 is 30. I'm doing half for all of these because I'm trying to find the angle. The inscribed angle is always half the intercepted arc. All right, looking down at angle 4. Angle 4 starts down here at vertex M. It goes up to L and up to K. So LK is its intercepted arc. Our LK has a measure of 80 degrees, so half of that is 40, so that's the measure of angle 4. Measure of angle 5. Now, I'm going to stop for a second. The only reason I'm doing this so quickly is because I know they're all inscribed angles. And I know if I can find the intercepted arc, I can just simply divide by 2 to find the inscribed angles. If they weren't inscribed angles, I would have to do something different. Unpause. So 5 starts down here at angle N, goes up to L, goes up to K. So LK again. So since it goes into the same arc as the previous one, it's going to have the same measure, which is kind of cool. We'll know that 4 and 5 are congruent angles because they go into the same intercepted arc. Nifty. And then our last one is 6. Starts up here at K. K goes down to N and goes down to M. So N and M, which we had another one of those over here. And so half of 60 is again 30. So another cool thing, we know angle 3 and angle 6 are congruent because they both intercept the same arc. Okay, so we've done measures of inscribed angles today. Last lesson we did measures of central angles. You now, for your distance learning assignment for today, there's a quizzes assignment. Okay, now I forget how many questions exactly, but you need to get at least 83% accuracy. So keep going until you get that. And once you get the 83% accuracy or higher, then you'll have received full credit for it. Some of the questions, it's all multiple choice. Some of the questions, it's not like typed out, like what is the measure of arc, blah, blah, blah. It's just in the picture. It might say like measure of arc AB, and that's what you have to find. So be very cautious in your reading to see what the values are. The next lesson on circles is going to be more with inscribed angles, but we're going to kick it up a notch as far as the difficulty level, and then also throw in some special cases. Okay, hope you guys are doing well. See you later.